Okay, so let's describe all of the transformation that this graph will have. Okay, so we know that our base function was, I'm just gonna write base was x to the power of 2, since that was the power. Now let's identify all of the parameters. The a value is equals to 4. The k value is equals to 0.2. The d value is equals to -2, since we know the base is supposed to be x minus d. Then we have c is equals to 1. From here on, we could start describing what actually happened to the graph. Also, please note the fact that it's not -4 as the a value, as simply the minus just signifies that it has been flipped onto the opposite side. Okay, so let's get going. Since we have an a value of 4, it has to be vertically stretched by a factor. Oh my god. By a factor of 4. And again, it was negative, which means it's a reflection in the x-axis. And then we have a horizontal stretch by a factor of 1 over k, remember. Let's start it. The factor is equals to 1 over k, which in our case is going to be 1 divided by 0.2, which is 0.5, which is 5, by a factor of 5. And since this is a number greater than 1, it has to be a stretch. We don't see a negative here, so there's no reflection in the y-axis. Then we have our x plus 2 component. Again, it is usually x minus d. Since we have a plus here, that means we're going in the opposite direction of what we usually consider right. You know, since it's right is positive. Again, right is equals to positive. And so left is equals to negative. Since we have a -2, we have a horizontal translation, and then we say units. So 2 units left. And then lastly, we have our c value, which is 1. It is positive 1. Therefore, we have a vertical translation 1 unit up. So our beautiful graph, which I will attempt at drawing, it's not going to be pretty. I already am telling you this. But I will try my hardest. So we know the base is going to look something like just a happy, good parabola. Definitely symmetrical, 100%. Don't even worry about it. Now, with the transformations we just learned, actually, let's make it like green. With the transformation we just learned, we have to first apply the a and k factors. So it was stretched by a factor of 4 and reflected in the x-axis. So it became skinnier since it was stretched. This is the first transformation. Then it was horizontally stretched by a factor of 5. So it now becomes something like this. Again, these are not symmetrical, and they definitely should be whenever you're doing this. Then we have our final transformations, which is, you could just combine them. 2 units left and 1 unit up. So our final graph is something along the lines of this. Again, you could do this with any sort of power function. So even if it isn't a quadratic, you could always just picture how you would transform a quadratic and then apply it to a different function. Like a quartic would be definitely almost the same thing. Things like odd functions might be a little bit more tricky, but you could just think of them in 2 halves and that'll make your life easier. But overall, this is how you do these sort of transformations. Again, please don't be as messy as this graph is. I can't humanly draw that well on a computer, but in real life, when you're using a pen or a pencil, please make sure you do it carefully.